Hello friends, continuing our discussion on clean rooms, indoor air quality and filters in HVAC industry, we would be looking into two major types of filters, namely the HEPA filters and the ULPA filters. Filter types based on filtering level, they can be categorized into 6 broader categories. One is known as the coarse filters. Coarse meaning the sizes of the particles which are being trapped by these filters, they are bigger in size. So the filters that are efficient in trapping the coarse dust particles, they are known as the coarse filters. Then comes medium efficiency filters, which also trap sizable particles, that is fine dust particles, but that sizes would be below the coarse filter sizes. Okay, so depending upon as you move from the coarser dust particle filters to the more finer variety, you graduate accordingly from coarse filters to medium efficiency filters to fine filters to efficient particulate air filters, and then to HEPA filters and ULPA filters. So we would be discussing the two major types, that is the HEPA filters and ULPA filters in this short lecture. What is a HEPA filter? HEPA. It is an acronym. HEPA is an acronym for H for high, E for efficiency, P for particulate, and A for air. So it's a high efficiency particulate air filter. So these filters, they are highly efficient in trapping the ultra fine particles. So how fine? How fine? So the size has to be remembered, the size of 0.3 microns. So as small as the airborne particle size of 0.3 microns. So this is the particle size which the HEPA filters can take care of. That is, it can filter. So it can remove, and it can remove at least 99.99% of the dust, pollen, mold, bacteria, and any airborne particles with a size of 0.3 microns. Okay, that is micrometers. So this is HEPA filters, and it is a pleated mechanical air filter. Okay, so construction wise, it is a pleated type variety. Okay, but from the filtering media perspective, the level to which it can filter, okay, it is the high efficiency filter up to getting you the filtering efficiency between 99.95% to 99.99%. Okay, and this, as you see, is used in clean rooms and applications which demand that such smaller size airborne particles are also to be removed. Okay, and how small? Remember this number. It is 0.3 microns. Okay. The second filter, which is equally good, but it is more efficient. Efficient in the sense that it can trap ultra fine particles in a highly efficient manner, more efficient than the HEPA filters, and it is ULPA filters. And what is this ULPA? ULPA. So U stands for ultra, L stands for low, and P stands for penetration. Okay, so ultra low penetration air filters. These filters are very efficient. They are highly efficient in trapping ultra fine particles. Okay, and how fine? So they can remove at least 99.99%. Okay, 99.9995% to be more precise. 99.9995% to be more precise of the dust, pollen, mold, bacteria, and any airborne particles with the size. And remember this size is much smaller than the size which we talked about for HEPA filters. For HEPA filters, what was the size? It was all the particles above the size of 0.3 micrometers for HEPA filters. And here it is all the particles with the size of 0.1 microns and above. So 0.1 micrometers and above, all the particles would be filtered by alpha particles. And by all, we mean 99.9995%. Okay. So this is the alpha filter. Remember that you would have different standards which would give you a slightly variant definition of what is a HEPA filter. And for example, if it is EN 1822 standards, then this would define it in a slightly different way, the HEPA filter. If it is IEST RPCC 001.5, then it would be a different definition. But more or less, the efficiency level is almost the same. And one thing is clear that alpha filters can remove very, very small, very, very fine particle sizes, more efficient. Now, what is the similarity and what is the difference between the two? Okay, that is to be discussed. So both the HEPA filters and alpha filters, they are used in commercial air conditioning systems, including in clean rooms, to trap extremely small contaminants. And we had discussion on what are the contaminants. So both this HEPA and alpha filters are used widely in commercial air conditioning systems. And construction wise also, both the filters, they use layers of dense fibers to create a fine mesh filter. And once that mesh is created, that mesh actually removes the contaminants. And how is, when is that contaminant removed? When you are forcing the air through them. Okay, so when you force the air through this filtering media, which is a fine mesh filter, the contaminants are removed. And there is a process of removal of contamination, which we had discussed elsewhere, which is diffusion, then there is interception, and then there is a inertial impaction. So these three methods which are used in filtration technique, that is diffusion. Diffusion is basically predominant on ultrafine particles and on the movement of these particles which follow the Brownian motion. Okay, so this diffusion is a technique which we will discuss later for particle capture. Then interception is where you particle is big enough, bigger than the one which is trapped by diffusion. So slightly bigger level particles, they are trapped by the method of interception. And finally, the slightly larger particles, they are trapped by a technique called as impingement or inertial impaction. Okay, so these three methods are also used to trap the contaminants in both these filters, that is HEPA filters and alpha filters. And as I said, the difference lies here, that the HEPA filter is relatively less efficient and it can filter the particles down to 0.3 micrometers, whereas the alpha filters is slightly better. It has a filtering efficiency of 99.9995% and for particles down to 0.1 micrometers. Okay, so this you need to remember. So HEPA filters and alpha filters, we must always be very clear when we talk about clean rooms, when we talk about maintaining the indoor air quality. I hope that my special focus on these two filters was worthwhile. Okay, and we would do this we'll continue our interesting discussion on clean rooms and how to maintain the indoor air quality. Thank you. Bye for now.